Imagine a world painted in shades of red. Endless rust-colored dust, sleeping volcanoes and vast silent deserts. This is Mars as we know it today, cold, dry and seemingly lifeless. Our robotic explorers send back images of a magnificent but desolate landscape where the air is too thin to breathe and water cannot last on the surface. But what if this isn't the whole story? What if Mars was once blue? A planet with a thicker atmosphere, a warmer climate and vast oceans. Science now suggests this was real, a young Mars with waves lapping ancient shores, rivers carving valleys, and clouds drifting through a sky not unlike our own. The Mars we see today is just one chapter in a much longer, more dramatic story. The contrast between the red desert and the ancient blue world is staggering, and it's one of the greatest mysteries in our solar system. How did a world full of water become the barren desert we see now? We're piecing together this story, clue by clue, using the tools of science. Planets are not static. They change, evolve, and sometimes lose what made them special. The story of Mars's lost water is both a cautionary tale and a hopeful one, showing that the ingredients for life might have existed on worlds right next door, and if they existed once, could something have taken hold in those ancient waters? The red dust of today may be hiding the blue secrets of yesterday. How do we know Mars once had oceans? The detective work starts from orbit, where spacecraft like Mars Reconnaissance Orbiter map the planet's surface in detail. These maps revealed the northern plains, vast, low-lying and smooth, looking exactly like a dried-up ocean basin. But a basin isn't enough. We needed chemical evidence. Rovers like Curiosity and Perseverance analyzed Martian rocks and soil, finding minerals like clays and sulfates that form only in the presence of water. These water-formed minerals, especially around the northern basin, are like salt deposits on a dried lakebed, a chemical fingerprint of ancient water. The combination of topography and chemistry paints a compelling picture. The northern plains likely held not just one, but possibly two great oceans in Mars's past. Arabia and Deuteronolis, two ancient seas, may have come and gone as Mars's climate changed. Each mission uncovers more of this lost water world, making the ghost of ancient Mars more real with every discovery. The evidence is mounting, and the story of a blue Mars is becoming harder to deny. We are looking at the ghost of a water world, and with every new mission, that ghost becomes a little more real. Imagine searching for a billion-year-old shoreline on another planet, a line battered by wind and meteorites. Using high-resolution maps, scientists traced subtle features along the northern plains, a planetary bathtub ring. They found ancient shorelines, vast formations snaking for thousands of kilometers, separating smooth plains from rugged highlands. The altitude of these features is remarkably consistent, just as you'd expect from the edge of a massive, stable ocean. But the shorelines weren't perfectly level. Some were kilometers higher or lower than others, a puzzle at first. The answer: Mars's crust deformed under the immense weight of the Tharsis volcanoes warping the ancient shorelines. Once scientists accounted for this planetary wobble, the shorelines lined up perfectly. This discovery not only strengthened the case for an ancient ocean, but revealed a dramatic history of volcanic upheaval and planetary transformation. The ghostly shorelines are more than lines on a map. They're scars telling the story of a world alive with geological activity. We weren't just finding the edge of a lost sea. We were uncovering Mars's dynamic past. These features are the silent witnesses to a time when Mars could hold an ocean, and then changed its very shape. The evidence is written in the land itself. If Mars was once wet, it should be covered in features carved by water. Rivers, deltas, canyons, and lakes. That's exactly what we find. Networks of dried-up river valleys crisscross the highlands, flowing toward the northern basin. These aren't random cracks. They're dendritic patterns, carved by persistent water flow over long periods. Where rivers met flatter areas, they formed deltas, fan-shaped deposits of layered rock, undeniable proof that water once flowed into standing lakes or seas. The Perseverance rover is exploring one such delta in Jezero crater, reading the pages of Mars's watery history, but the water trail doesn't end on the surface. Enormous amounts of water ice are frozen underground, especially near the poles. Radar instruments have mapped these hidden reservoirs, some vast enough to cover the planet in a shallow layer if melted. Not all of Mars's water was lost. Much of it may still be there, locked away in a deep freeze. If Mars once had an ocean, where did all the water go? The answer is a planetary scale mystery. The solar wind is the first culprit. Without a strong magnetic field, Mars's atmosphere was stripped away by charged particles from the sun. As the air thinned, water could no longer remain stable, it boiled away and was lost to space. The second theory, crustal hydration. Water reacted with volcanic rock, becoming locked inside the minerals, turning rock into a sponge. Over billions of years, this process could have absorbed a tremendous amount of water, trapping it underground. Finally, as Mars cooled, remaining water froze beneath the surface, protected by dust layers. Today we find this frozen water at the poles and mid-latitudes. So Mars's water vanished in three ways: blasted into space, soaked up by rocks, and frozen underground. The transformation from blue to red was slow, relentless, and left behind the cold, dry world we see today. The search for the missing ocean continues, but the clues are all around us. Nowhere is Mars's watery past more dramatic than Valles Marineris, a canyon so vast it dwarfs the Grand Canyon. Once thought to be just a tectonic crack, closer study reveals water played a crucial role in shaping it. Catastrophic floods, unleashed from underground reservoirs, scoured the canyon floors and carried debris toward the northern plains. The canyon walls expose billions of years of geological history, with hydrated minerals layered between other rocks, evidence of changing wet and dry periods. Mars's climate wasn't a simple transition from wet to dry, it cycled, and the record is written in the canyon's strata. Even today, Valles Marineris may hide water. Recent discoveries show high concentrations of hydrogen, likely from ice or hydrated minerals just beneath the surface. This makes the canyon a prime target for future exploration. Valles Marineris is a monument to the power of ancient Martian water, and may still hold its secrets. Why do we search for water on Mars? Because on Earth, wherever there's water, there's life. Billions of years ago, Mars had oceans, lakes, rivers, and a thicker atmosphere, conditions similar to early Earth. This period was a window of opportunity for life to emerge. Our rovers are astrobiologists searching for biosignatures, fossilized microbes, chemical patterns, or organic molecules in ancient rocks. The best places to look are ancient deltas like Jezero Crater, where Perseverance is collecting samples for future study. The search for life on Mars is about answering one of humanity's deepest questions: are we alone? Even the simplest fossilized microbe would be a discovery that changes our understanding of life in the universe. The search for water is the first step on that journey. The story of Mars and its lost oceans is more than planetary science, it's a lesson about our own place in the cosmos. Mars shows us how worlds can change, and how losing a magnetic field and atmosphere can transform a planet's fate. By studying Mars, we learn what keeps Earth habitable and appreciate our own world's delicate balance. The journey of discovery is just beginning. Future missions will drill deeper, search for hidden ice, and bring Martian samples back to Earth. Every new image and data point adds to Mars's biography, transforming it from a point of light to a complex world with a dramatic past. This knowledge expands our cosmic perspective and fuels our curiosity. The drive to explore is part of what makes us human. We look to the red dust with wonder, knowing it hides the ghost of a blue world. The story of Mars reminds us the universe is full of surprises, and there's always more to discover. The cosmos is waiting, and Mars is just the beginning.